Hey everybody! Today we are going to take a look at multiplying and dividing these crazy fraction rational expressions, okay? You need your notes, something to write with, calculating device. You know factoring is going to be a part of what we do, so just be ready for that. Today we need to know how to simplify them. Still working on that. We're going to do so when we have multiplication and division happening. So we need to remember the rules that we learned in elementary school and middle school when we talk about multiplying fractions. When you multiply two fractions times each other, you basically multiply straight across the top. And you've done these in geometry and algebra 1, okay? So when you multiply two fractions, you're going to take across the top, 1 times 1 makes 1, and then 4 times 5, 20. So you multiply the numerators, multiply the denominators, and then simplify your answer at the end if you have to, okay? When you divide fractions, you want to multiply by the reciprocal. So when we have 1/4 divided by 1/5, we can change that to 1/4 times 5/1 and then multiply straight across to make 5/4. So we're basically using our fraction rules that are basic here with just numbers to illustrate what we're going to do today when we have crazy algebra expressions in those factors. Always make sure at the end that you're always simplifying your answers, okay? What if I was asked to do this crazy multiplication problem? Well, geez, you guys, these numbers are going to get pretty big really fast. And what if I don't have a calculator and it's like 15 times 12, and then I'm going to have to divide 60 by that number? Ugh, gross. So you probably can remember when you've simplified fractions using the idea of just basic simplification, right? This is still just 20 times 3. I don't actually have to multiply that. Ooh, geez. And then on the bottom, it's just 15 times 12. But if I think about them in factored form, 20 is the same thing as, let's say, 4 times 5, and 15 is the same thing as 5 times 3, and 12 is the same thing as 4 times 3. Just breaking it apart even with simple factors, you can reduce before you actually multiply. So notice I have a 5 here over the top of a 5 here. I can simplify that. And this 4 on the bottom here, I have a 4 on the top over here. I can simplify that. So, and I have a 3 on the top here that I can divide by this 3 right here. Nice. So in the end, all that's left for me is just this 3 left on the bottom, right? So my answer would just reduce to be 1/3, and I didn't actually have to multiply anything and get big numbers. I used the idea of factors to help me cancel away things before I actually multiply. That's pretty cool, huh? Well, we want to think about that same thing when we do our multiplication. We want to think about, let's not really distribute this out, you guys, because then we're just going to have to break it apart at the end anyway. Let's break it apart first and see if anything simplifies before we actually do any multiplication at all, okay? So in the numerator here on the top of this fraction, let's break him apart. What can I divide out of both of those terms? Looks like a 2 and an x, leaving me with x minus 5, right? In the bottom of that fraction, this guy right here, I can break him apart into x plus 5, x minus 5. That's handy. I feel like something might reduce right there. Okay? The top of this fraction is just x plus 3, so I'm going to leave that alone. And the bottom of this fraction is 2x squared. So if I think about this, what would I have if I wrote everybody straight across the top times each other? So basically 2x times x minus 5 times x plus 3. And on the bottom, I would have an x minus 5 and an x plus 5 and a 2x squared. I think I'll write that guy in front. So what would I have that's the same on the top and bottom? You can see it already, right? You can see the x minus 5s would cancel. And here you have a 2x and a 2x squared. Those are factors. So we can cancel that. 2 over 2, right? An x over the top of an x squared. What would that reduce to make? Think about that. X over x squared means I have x times x. So I'd have one little x left on the bottom if I were to reduce that. That's kind of cool. So we'd have one little x left on the bottom. So I'd have x plus 3 is the only thing left up on top by the time I cancel everything. And one little x is left on the bottom with the x plus 5 that didn't have another factor x plus 5 to cancel with. So this is actually my answer for this multiplication problem. I didn't actually multiply anything times each other. I've simply factored and looked for things that would cancel, just like we've been doing before. Okay, so let's take a look at another one like that. What if this says multiply? Hint, don't actually multiply, right? Factor things out to look for things that cancel. So what would I divide out of both of these terms here? They both have a 4x, so I'm going to divide out of 4x, leaving me x minus a 1. Remember, 4 divided by 4 makes 1, not 0. The bottom of this guy I can break apart. In the front of these parentheses, I'm going to put an x and an x. In the back, I need to multiply to make negative 3. Well, 3 and 1 could do that. If the 3 is positive and the 1 is minus, then it would add to make 2 like I want in the middle. So now he's all broken apart. Well, what's on the top up here? Well, let's break that guy apart. What goes in the front? X's and X's, right? Back, I need to multiply to make a negative 6. Plus 3 minus 2, because I need him to add to make 1x in the middle. And then on the bottom here, I have a 4x. So think about what would be all along the top and what would be all along the bottom. Well, I'd have a 4x, I'd have an x minus 1, I'd have an x plus 3. Now, you don't actually have to write all these out again if you don't want to. You could simply start canceling right now. X plus 3, x minus 1. Think about who would cancel. X minus 1 would cancel, right? X plus 3 would cancel. Yep. 4x. What's the only thing that's left? X minus 2 left on top. Awesome. So all I have left is this x minus 2, and that's my simplified answer. That's as simple as he gets. Didn't actually multiply anything, just factored and canceled. All right, let's take a look at a third one with multiplication. The top of this fraction's x plus 2. There's nothing I can do to break that apart. It's not squared or anything. So think about that as like an x plus 2 in parentheses already. The bottom, x squared minus 4, that can be x plus 2, x minus 2. Now this one over here doesn't look like he's a fraction, right? But every number's technically a fraction if you put it over 1. So what I have on the bottom of that fraction there is just a 1, but now I need to split apart the top. That's got 3 terms, so we're going to throw x's in the front. What do I need to multiply to make 9, but add to make 6 in the middle? 3's will do that. There we go. So take a look at what would cancel here. I see x plus 2 would cancel over x plus 2. And basically what I would have left is x plus 3 on the top, 2 of them. So you could write that as x plus 3 squared on top over x minus 2 on the bottom. There we go. That's my simplified answer. And the last one. Now, what if it says divide? Are we actually going to divide anything here? Well, if I'm dividing two fractions for each other or by each other, here I would actually multiply by the reciprocal. So 2x and 3x minus 12 gets multiplied by, and we want to flip this second one. You cannot flip the first one, ladies and gents, because division is the same thing as multiplying by the reciprocal. I'm dividing by this. It's like saying 6 divided by 3 is the same thing as 3 divided by 6. Not the case, okay? So we need to be sure that we flip the second one. I'm going to flip him over here. And then we do the same thing we did before. We turn this divide into a multiplication sign, break it apart, see what cancels. So on the top of this first fraction, I just have a 2x. The bottom, what can I take out of both of those terms? 3, leaving me with x minus 4. The top of this fraction, 3 terms, so I'm going to pop down some parentheses, x. What multiplies to make 8, but adds to make negative 6? Negative 4, negative 2. That'll do it. In the bottom of this, I have 2 terms only, but they both have an x in common. So then I'd have an x sitting outside, and then I'd have x minus 2 left over when I take that x out. So before I even write what's left, remember, think about this. When you multiply two fractions, they're just going to go straight across. All this stuff on the top is going to be on the top. All the stuff on the bottom is going to be on the bottom. So basically, this is like one big fraction sign here. And now we just look for things that can cancel. I have an x minus 4 on top, x minus 4 on the bottom. X minus 2 on top, x minus 2 on the bottom. Here's an x. This is 2 times x, right? And here's an x down here. The x's can cancel. They're not joined by any adding with anybody else. So I can cancel them. So all I have left here is a 2 on top. And what do I have left on the bottom, you guys? That's it. 3. This is the number 2/3. Wow, we didn't see that one coming, did we? All this multiplies to make, or divides in this case, to make 2/3. Okay? So that's the end of our notes today. Think about this whole idea of factor cancel. We're just extending it now to multiplication and division when we have those fractions, double fractions, they're happening, okay? Remember with divide, you're going to flip the second one and multiply, and then remember break it apart, okay? Kid and Kate out.